Assalamualaikum warahmatullahi wabarakatuh. Today we want to present our mini project for digital system 2. Our mini project called Smart Home Multi-Light Control System. We are from group 5. That is our group members. Leader for this team is Wan Muhammad Akil Dewan Kamal. Our group members is Ahmad Najmi Firdaus bin Ahmad Faris, Muhammad Ashraf Hakim bin Abdullah, and Hafiz Izzuddin bin Muhammad Razif. Chapter 1 for introduction, we brief about this project. Smart Home Multi-Light Control System is designed to demonstrate a digital system that controls multiple light in a smart home environment. This project is constructed by using basic digital logical component that is built in within the quarters 2. The system used the application of a total 3D flip-flops in this operation. We go for motive of the project. We did some research on the internet and found out that electrical energy waste have been one of the biggest issue in a household environment. According to Western Australia's largest electricity provider called Synergy, the average household use around 5,300 kilowatt hours of electricity per year. 26% of those were wasted through inefficient and unused lighting around the house. The use of indoor electric lighting is essential for creating a comfortable and functional home environment. However, when lamps are left on unnecessarily, they contribute to significant energy waste. To avoid the energy waste, we have created this project to control a multiple light in different rooms with a single switch. We go to objective of this project. Number 1, to design a fully working circuit system using 3D flip-flops. Number 2, to use the concept of parallel in and parallel out concept in the system. Number 3, to create a single switch that can be used to turn off or turn on all of the D flip-flops, we known as main switch. And we go for scope of works. The project's work have been evenly split within our members, and the works includes we creating a truth table of a parallel in, parallel out for shift register. We designing the logic circuit within the quarters 2 application using flip-flops. And last, we run the simulation and comparing the result with the theory using the waveform simulator in quarters 2.
So now I will talk about chapter 2, truth table and circuit diagram of the system. First column is clock, represent the clock to control the system. Assigned to key 3, which is the push button under the keyboard. The column number 2 is main switch, represent the main switch to control all the light. Assigned to switch 0 and input switch 0. For column 3, 4 and 5, it represent the light switch to each light. Is the input column. The individual input correspond to each of the flip-flop. Assigned to switch 17, 16, and 15. Input switch respectively. For column 6, 7, and 8 is the output column. Represent the output of the light. The individual output correspond to each of the flip-flop. Assigned to LED green 7, LED green 6, and LED green 5. LED output respectively. From column number 9 is 7-segment display, used to display the number of corresponding light in the. So now for the 2.2 circuit diagram. The system used the principle of parallel in and parallel out (PIPO) to implement the behavior of a light switch. The system is built of 3D flip-flop, each have their own individual input and output. The output of the flip-flop is then connected to a 7-segment display to display the number of active LED light. This is the following screenshot is the circuit diagram of the system that we make. Component used in the circuit consists of 3D flip-flop used to store the data of each input, XOR gate, AND gate, OR gate. Since the 7-segment display only accept binary input, we have to translate the output of the circuit into binary before handing it over to the 7-segment display. 7-segment display used to display the number of lights that are activated. This system converts the state of multiple switch into a binary coded LED output and a decimal number on a 7-segment display. It's a basic implementation of a multi-light control system that visually represents the number of active switch using a digital display. Okay, that's all from my part.
Chapter 3: Problem Statement, Troubleshooting, and Outcome. First, let's talk about the challenges we faced and how we solved them. The first problem we encountered is the wrong usage of flip-flop type. In our initial mockup, we used the JK flip-flop. However, we soon realized this wouldn't work because our inputs needed to have their own individual outputs. Since our circuit follows the parallel in and parallel out principle, we switched to a D flip-flop, which better suited our design. The second problem we encountered is preset and clear connected to VCC. One of the key features of our project was the ability to turn off all flip-flops with a single switch. Initially, we connected the preset and clear to VCC, but later realized this setup didn't allow us to disable all output at once. The way we fixed this is by connecting the preset and clear of each flip-flop to an input switch. We made it possible to turn off all of the flip-flops simultaneously, successfully disabling all output with a single switch. The third problem is giving input to the 7-segment display. Our design had 3 outputs, but we faced a challenge. The 7-segment display in Qualtus 2 application only accept binary coded decimals input. To fix this, we first converted our 3 input into a binary number using XOR and an OR gate. By following the truth table for these gates, we successfully translated the output into a format that the 7-segment display could recognize. We refer to the truth table below, as shown in the image. The fourth problem we encountered is wrong key assignment. When we tested our circuit on the DE board, we encountered an issue. It wasn't working as expected. After a throughout check, we discovered that the clock input was mistakenly assigned to an LED instead of a push button, which is a common mistake among students. We fixed this by reassigning the clock input into a push button, which solved the issue. Outcome of the project. After various troubleshooting, our project functioned as expected. The 3 inputs successfully controlled the LED outputs. The main switch could turn all flip-flops on or off simultaneously. The 7-segment display correctly showed the 7-segment display correctly showed the number of LEDs that were turned on at any given time.
Chapter 4: Conclusion and Future Improvement. 4.1 Conclusion of the project. With our basic model of smart home multi-light control system, we believe that the community can use our system to reduce the overall usage of electricity around the household. Our basic model can also be used to reduce light pollution. That has been an issue for the whole globe, but often underlooked by the community. 4.2 Future Improvement. We can introduce the usage of a motion sensor. There will be a motion sensor placed at each of the room. If the motion sensor detects a person has walked into the room, the lights will be automatically turned on. Then, if the motion sensor detects the person has left the room, the lights will be automatically turned off. This can further reduce electricity waste.